So my talk is called Intentional Swift. It's about communicating your intentions more clearly in your Swift code. So when you're reading someone's code, it can become confusing pretty quickly, and all this confusion can cause loss of productivity, more bugs, and a host of other problems. So in this talk, I want it so that after you implement these things, people look at your code and they won't say what's going on. We spend a lot more time reading code than we do writing, and a lot more time debugging as well. So in theory, if we spend a bit more time doing the writing, we'll save a lot of time in the reading and debugging. In this talk, I'm going to talk about three things. The first one is going to be just kind of quick wins. So these are basic things you can put into your code. And some of them will be kind of obvious. Hopefully you're doing a lot of them, but I think a lot of them bear repeating. The second are some higher level concepts that will help you communicate things clearly. And the last one are just some tips that help me when I'm trying to implement these things. All right, so very first off, picking the type. Different types communicate different things. So if you're going to use a class, you're communicating that everything needs to talk to the same reference, or reference the same object. You need a pass by reference. With a struct, you're saying it's fine. You can copy this all over the place. And with an enum, you're expecting a list of related values. So if you use one of these in an unexpected way, it adds a lot of confusion, and people will read it and not really know what's going on. So lately, a lot of people have been using enums to just sort of hold a few static properties, not have any cases, no related values. And I think that's a lot like if you were trying to tell people what the biggest city in Chile was with a table. Technically, it works. It does tell you what the biggest city is, but it's really confusing as why you would use a table. And when you read that, you don't really understand what's going on. Next is naming. This is the biggest thing that contributes to how readable your code is. It takes a lot of time, but it's generally worth it. So just a quick thing is for classes, call them what they are, a user. For functions, name them by what they do, such as fetch current user. Next is access control. So there's three levels of access control. Public means your code can be accessed by any file in any module. Generally, this is just for frameworks. Internal is what you'll mostly use for the classes in your app. It can be used by anything in your module. And then private can only be used in that file. So this communicates a lot, obviously. And it's important to mark your classes and methods as private or internal so that people know how they're intended to be used and people won't access data incorrectly. Another keyword is final. This means that your class cannot be subclassed. So if you haven't built or tested it for subclassing, you should put the final keyword in front. Another obvious one is using named constants. For strings and numbers, it makes a lot more clear what you're doing, and also breaking up big chained methods into well-named functions makes it clear, and you can scan through your methods pretty quickly. Custom types. So sometimes you only want to have very specific data that can go in or out of methods. So for example, you might have analytics in your app. And instead of allowing anyone to just put any kind of string in there, you might define something like an event enum. And it makes it very clear that only events can be used for analytics. And then instead of allowing people to put any kind of dictionary or string into these, you know that they can only put an event or a property. Breaking up big functions. So this is a not so uncommon view-did load method. All these different blocks of text do different things, set up different parts of the view. So instead of this, breaking this up, having a bunch of small methods that each have a good name, and then putting all the details down lower, gives you something like this at the high level where you just see, okay, I'm setting up the navbar, setting up the view, registering some observers. It's very easy to scan through. And then once you do break this up, make sure that all these things only do one thing, or that a class only has one responsibility. If you have something that does multiple things, you might end up with something like this. Say you're creating a grocery list, and then you realize that you have something else to do, taking your cat to the vet. You're feeling kind of lazy, so you don't really want to get another piece of paper, start a new list. So you just add it to your grocery list. And then later when you're checking back, you think everything's good, you've done everything, but your cat is still sick at home. So here's a quick summary of the things I talked about. Using appropriate types, using good access control, marking things as final. And then once you've made your class, using name constants and constant type or custom types so that things are clear. And then breaking up functions and making sure all the small functions just do one thing. So the next part is some higher level concepts. The first is about how we store data. So we can think of all of our structures as either objects or data structures. And there's one big difference between them, which is that objects should hide their data and provide abstract methods into it so that you only manipulate data through abstract methods and you don't know the internals of it. So for example, you might have a team manager, you're adding a user to the team. You shouldn't really know how that's working internally, you just want that to happen. On the other side, data structures should expose their data. So for example, a CG rect, you can access the size, the origin, the height, all those things directly, and it doesn't really have any meaningful methods outside of that. The next is, an example is where problems sometimes happen is you have a model which is just kind of a dumb data structure, but you start putting more logic into it to format the data or do network requests. And in this case, you should probably have an object that wraps that data. The object can access all the properties, and then the object can have more abstract methods that you call into, so you don't need to know all the details of those functions. For example, if you're getting a sorted list of the team members, you can call an object for that. Another concept is using protocols. So Steve talked about this a little bit. It's nice that it adds a bit of a header file to your class, makes it explicit what should and can be called. You can then just pass the protocol around as though it were the type, and then people can't access anything else within your class. And when you have a type that's conforming to a bunch of different protocols, it gives kind of a nice short summary of it. So this is from the standard library. It's a collection, and just looking at this one sentence, you can see that it's a sequence and you can index into it. So lastly, just a few tips. The first is keep your things small. So when you have classes or methods that are small, they just do one thing, they're much easier to name. When things start to get bigger, they do a bunch of different things. It's really hard to think of a name for them. And when you keep things small, all these other points just become a lot easier and kind of fall into place. Another thing is using a consistent architecture. So if you're doing something consistently, you have a bunch of the same components reused over and over. And every time you see those, you have an expectation of what it's going to do. So it's a lot easier to scan through it. So if we're using presenters everywhere, you know that that's always going to request data, present it for a display, and it's easy to understand what that's doing. So the last thing is, after you write something, it's probably going to be a bit messy at first. You've just kind of put a bunch of stuff into one thing, you haven't named it very well. It's hard to organize everything when you're just trying to get all your ideas out. So afterwards, once it's functional, you can break it up, organize it a bit, give it good names, and it'll be a lot more readable for you in the future and everyone else that's reading your project. And that's it. Thanks for listening.